Today we're in the last lesson of Unit 6. We're still in Lesson 6. This is Day 2. We're looking really at operations with complex numbers, which you saw in Algebra 2, and we're going to expand that to operations with polar numbers as well. So the first thing they've asked us to do is we've been given the following two complex numbers. They wanted us to find the product, the quotient, and z squared. So we've got 3 minus 2i and 1 plus I. So like I said, let's treat it like Algebra 2. We're just going to FOIL it out. We end up with 3 plus 3i minus 2i minus 2i squared. Remember, I squared is equal to a negative 1, so this ends up being plus 2, and we've got 5 plus I. And we'll come to the polar form here in just a second. Let's go take a look at the quotient. And we are looking at z sub 1 divided by z sub 2. So that is 3 minus 2i over 1 plus I. Remember, when you're dividing, we have to multiply by the conjugate. And I'm going to give you a minute to go ahead and work that through and put your final answer over here. Okay, this is what I got for my final answer. You may have stopped here, which is fine. If we truly want to separate out the real and the imaginary, we could take it one step further. All right, let's go look at the last one, z sub 2 squared. So we've got 1 plus I squared, which is 1 plus I and 1 plus I. So we'll FOIL that out. 1 plus I squared. Again, this would be equal to negative 1, so the 1 and negative 1 cancel out, and we are left with 2i. Now, that's what you did in Algebra 2. We're going to take it one step further. We could take each one of these and we could change it to polar form. So remember, we need to find the magnitude, which is the square root of the components, which is 5 and 1. So that's 5 squared plus 1 squared, which would equal 26. I need to go and find the angle, so that means I've got inverse tan of 1 over 5, and we end up with 0.20. And let me go and check what that would be in terms of a degree. So the 1/5 was just the 0.20. Inverse tan of 0.20 gives me 11.3 degrees. So in polar form, if you recall, that is r cosine theta plus I sine theta. We end up with then radical 26 cosine of 11.3 degrees plus sine I sine of 11.3 degrees. Now I just want to point out, if I was to go ahead and distribute this, I should end up with something close to 5 plus 1i. So let's just double check that. So radical 26 cosine of 11.3, and we get 5, which is what we expected. Again, radical 26 times the sine of 11.3, and we should get something close to 1, and we do. So again, just confirming that these are the same. Okay, let's go on to the next one, and again, you want to change it to polar form. I'm going to give you a minute to go ahead and do that as well. So find your magnitude and find your angle as well. Okay, my final answer in polar form is what I got here. This should be a negative as well. And the only thing I just want to confirm, I'm truly in the right quadrant. So this is a positive and a negative. So if we roughly had to graph it, 1/2, negative 5/2 would be here. And again, if I wanted to check it, I could. I could go and do 2.5 cosine of negative 78.7. And I should have been doing so I did the y first, which is negative 5/2, pretty close to that, and then 2.5 cosine of negative 78.7, and I should get close to 1/2, and I do. Okay, last one in polar form. So again, if I want to find my magnitude, or r, if you think about this, 0 plus 2i, so that would be 0 squared plus 2 squared, which ends up giving me 2. If we want to go and find the angle, so we are doing inverse tan of 2 divided by 0, which means we're looking for when is the tangent. This is equal to undefined, which would be at the top of your unit circle here, which is 90 degrees. So again, in polar form, we would have 2 cosine 90 degrees plus I sine 90 degrees. So as I said, column 1 and 2, you did in Algebra 2. We're simply adding on here, but really you did this in the last lesson. Okay, so now we're going to take a look at what if the vectors or numbers that we've been given are already in polar form. So instead of taking them from polar form back to imaginary, multiplying and then changing back, we've got other ways to go ahead and do that. So let's flip to the back of the notes. So they define, if you take a look, Z1 and Z2, these are polar form numbers. And if we wanted to multiply them, take a look at what you do. You multiply the two magnitudes and then you add the angles. And again, you'd add the angles over here. So if you look at that, that's a whole lot easier than changing these, as I said, to imaginary, then multiplying and then back to that polar form. So let's take a look at this formula. So we're taking our two magnitudes, 7 times 2, and then we've got cosine of 25 plus 130 plus I sine of 25 plus 130. So we end up with 14 cosine of 155 plus I sine of 155. Now the directions say leave it in polar form, but if we wanted to go back, we could go and change it to complex form. So let's again, just trying to help you out. So just like we had kind of done on the front, we would go ahead and really distribute that. We've got 14 cosine of 155, and we'd have 14 sine of 155. And there's my two components. So we would have negative 12.6. Actually, we'll do 6.9 plus 5.92i. All right, let's go take a look at the next one. Again, you've got two polar form. You're multiplying them together. So again, using the formula here, we're going to take radical 3, multiply it by 1/3, and then we've got cosine of 3 pi over 4 plus pi over 6 plus I sine, again, 3 pi over 4 plus pi over 6. So radical 3 times 1/3, the best we can do is leave that as radical 3 over 3. We've got cosine. If we're adding these two, I need to go find a common denominator. So I'm going to go ahead and do that up here. I've got 3 pi over 4 plus pi over 6. I'm going to convert each of those to twelfths. So we've got 2 twelfths here. Here we've got 9 twelfths. Finally, we add those together and we end up with 11 pi over 12 plus I sine 11 pi over 12. Okay, moving on to the next one. Now it says to find the quotient. We'll take a look at the rule for the quotient. In this case, you take your two magnitudes and you divide them, and with the angles we are subtracting. So here we would just do 2 divided by 3, which we can't really do anything with, and we've got cosine of 30 minus 60 plus I sine of 30 minus 60. We've got 2/3 cosine of a negative 30 degrees plus I sine of a negative 30 degrees. And Math Excel tends not to write things using the negative, so let's go ahead and change this to what this would be positively. That would be cosine of 330 degrees plus I sine of 330 degrees. Now again, let's go ahead and practice on this one. I know it says leave it in polar form, but let's go ahead and change it. I'm going to see if I can't squeeze it in here. I've got 2/3. If I think about the cosine of 330 degrees puts me here. That's a long x and a short y. So that would be radical 3 over 2 plus 2/3 times negative 1/2. Simplifying that up, we have radical 3 over 3. if you notice, the 2's cancel here, and you've got minus 1/3 I. Okay, I'm going to pause, let you guys go ahead and try number 4. Okay, in this particular case, again, I divided the magnitudes. I subtracted the, in this case, radian measure. I got the following. If they did want me to take it to complex form, 2 times the cosine of 3 pi would be 2 times 1. And then looks like I left out a 2 in here. It'd be 2i times 0, but again, that gives you 0, so you're left with just plain old 2. Okay, then we can actually use something called de Moivre's theorem to raise these polar numbers to a power as well. So if you take a look, if you've got a polar number raised to a power, you're going to take that magnitude to that power, and then you are multiplying that power times the angle measure. So in other words, I'm thinking that this 4 is supposed to be in here. So if my magnitude is 4, I would take 4 to the 3rd, and then I have cosine of 3 times pi over 4 plus I sine, again 3 times pi over 4. 4 to the 3rd is 64. This would give us cosine of 3 pi over 4 plus I sine of 3 pi over 4. Again, if it says leave it in polar form if we're done, if we needed to take it to imaginary form, again, we could do that. That would be 64 times the cosine of 3 pi over 4, which would be negative radical 2 over 2, which is negative 32 radical 2. Over here, I would have 64i times radical 2 over 2. Again, 2 goes into 64 32 times, and we're left with the following. I'm going to go ahead and pause and give you just a moment to take a look at, oh, actually this one's a little bit different. So if we had, and I'm going to make it a little bit easier. So if you imagine this one, if we wanted to do what we did on the front, we'd have 1 plus I times 1 plus I times 1 plus I, etc. Our other option is to flip this to polar form and use this theorem here. So let's take a look. Our magnitude, or R, would be 1 squared plus 1 squared, which is radical 2. Theta would end up being inverse tan of 1 divided by 1, which is 1, which happens at 45 degrees. So I'm quickly flipping this to the polar form. We've got radical 2 cosine 45 degrees plus I sine 45 degrees, and we are raising it to the 4th power. So again, we're going to take our magnitude, raise it to the 4th power. That would be radical 2 to the 4th, which ends up being 4, and 45 degrees times 4 plus I sine, again, 4 times 45 degrees. I believe that ends up giving us 180. So we've got 4 cosine 180 plus I sine 180. And again, if we wanted to simplify it up, cosine of 180 degrees would be negative 1. And the sine of 180 degrees would be 0, so we finally end up with negative 4.